Welcome to the presentation of the paper Crowdsourced AI-supported IoT data modeling. I have problems with my voice, as you heard, sorry for that. So what is the paper about? Imagine you have two IoT devices, this one here and the other one here, and they are both offering the same functionality. Imagine they are controlling lamps, for instance. So when you want to talk to the two, or the two want to talk to each other, what do? Well, they exchange data. And what is interesting in the data? Well, many things, but especially the payload, which is the way the data is represented that the two exchange. And now imagine these come from two different vendors, and that typically means that if you want to control the one here, you have to send one data packet with a specific format, and if you want to control the other one, you have to use another format of the data representation. More concrete, if you want to switch that one on, you have to send whatever 42, and if you want to switch that one on, you have to send on. And while this is working, this is a central problem of the Internet of Things today: missing interoperability. What is its key, or the center of the missing interoperability? Well, it's the so-called data models or context models, so the models that define how the data is represented, that is used to do a certain data exchange. As you can guess already, it would be highly desirable if both would use the same data models, but this is difficult to achieve. And this is exactly where the paper kicks in. So we try to support developers, this guy here, in creating interoperable, because they are converged data models. Okay, let's start. I will not use the paper that we see here on the left, but the same information, just formatted a little bit differently. So here is the 16:9 format. I will present it to you step by step now in the following 8 minutes, starting with the authors. So this is joint work between me, my PhD student Christian, and our bachelor student Florian, and the entire work is based on a publication that I created in 2014, which is about crowdsourced context modeling. And crowdsourced context modeling means that there's not a vendor that is creating the data models for the IoT devices, but people have the IoT devices or create them themselves by 3D printing it and so on. And they work together with other people that create such context models. The key of this paper is that we have a so-called central model repository. So this is a space where everybody can upload their models, and they can use them within operating systems for the smart spaces. So I also presented, or we presented also such works in other papers. And now the key challenge is, how can we converge them? My conclusion back in 2014 was, okay, when I offer statistics saying like, okay, this is the amount of usages of a certain model, this already sets an incentive for the model creators and for the app developers to use these context models. With new advances in artificial intelligence, we can now automate this process, and we can automatically propose already existing models to the developers, and we can support them in the tagging and creation of these models. And this is exactly what we propose in this paper. So let's have a look at the abstract. So I will mark you the important parts here. So key is we want to have interoperability, and things interact by exchanging data, and therefore we need common standards in the data representation, so in the data or context models. The problem is that creating interoperable data models creates time, and often the models are domain specific, meaning if you have a gaming console and you have a developer of an AC device, they are typically not on the same table for standardization processes. Therefore, what we propose is a crowdsourced approach that uses artificial intelligence for unifying IoT data models already during creation by offering support in this creation an open repository and a concrete front end, which is an Eclipse-based editor front end and back end with the repository that checks both of them, syntax and semantics, and uses machine learning for tagging and auto-completion of models. Alright, and then in the end we evaluate the entire thing using the biggest data source for IoT data models existing today, which is Project Haystack, IoT Schema, and Brick Schema. Alright. Let's continue to the upper part here. So we want to have interoperability. For that one we need semantic models. We need to converge them so that when you have two devices that offer similar functionality, that they use the same data model and extend also existing data models, because the scheme that I proposed 2014 is a modular one where you can inherit and compose data models in order to create new ones, which equals to composing or inheriting functional interfaces when you think in an object-oriented world. So we want to converge them, and we propose today to use AI-based classification in order to do convergence and in order to increase the usability of the modeling scheme. So what is the pipeline that we propose? Well, we propose to use, for the developer, we use an Eclipse EDI, so they could also use any other IDE, but we created our prototype for that one, or Florian created it for that one. In the IDE here we can already do XSD syntax checking, because the data models that we have are XML based, as you see here. What is interesting is that here we create a data model, and this data model inherits from another data model, which is here the green one. And then you can create things in a modular way. More details in the paper. But interesting here is that when you create something new, you should reuse things that are already existing, because then you have more comparability for existing things in the ecosystem, like existing applications. So what do we add then? We add a model minimization and maximization. This is basically remove all the content that was already defined, because you can build on the shoulders of giants and you don't have to reinvent the wheel from scratch. And we also propose machine learning based tagging directly in the development environment here. When we see in a second how this looks like. When we go to the repository, there we do of course validation, because it's an invariant in this system that all the models that are checked in are valid. We store the information, and we have also a repository for tags and features. The machine learning based suggestion mechanism uses the features that you see here. We compared 4 methods here in machine learning. You will see it later. So 4 classifiers for these models. We do a weighted combination of the 4 that we have, and in the end we have proposed tags. So how does this look like in practice now? Let's have a look. So here is the interface, and now you will just see that it starts looking based on what you already started typing here for different data types, and it identifies several ones that are probably interesting to you. This is only a first prototype. You can already imagine where the story goes, so that you are typing, and while typing it's automatically completing and proposing new things. And so here you see a data model that is proposed now, that you could load now directly into the editor. Alright, so let's return and go to the last part of the presentation, which is the evaluation. So as said at the beginning, we used the biggest set of available data types, which is Project Haystack, IoT Schema, and Brick Schema, not data types but data models. What you see already in the correlation matrices at the bottom here is that the dataset is highly biased, so we have a long tail here with most of the tags being here on the left side, and this also reflects in the matrix here, and is of course a problem for our evaluation for the moment, but we just don't have different data sets. At the right side you see the 4 algorithms that we used, so the majority was used for backchecking, and you see that they all have different advantages and disadvantages. More details also in the paper. Alright, so now you have a quick overview. For more details, refer to the paper and also the other paper that I presented. I hope you enjoyed it. We are looking forward to discussing more with you and also collaborating with you. And yeah, see you in a minute in the discussion. Bye.